Now we're quickly going to go through some connecting theorems, postulates, and definitions that you can use to make triangle proofs. Usually you cannot go straight from seeing the picture of the triangle to saying, oh, they're congruent. Normally you have to do extra steps to show that either the sides are congruent or maybe the angles are congruent. So here's some helpful theorems and postulates. First of all, there's a vertical angles theorem. So you don't have to have this as part of the given in your proof. It can come from the picture. Just two lines crossing automatically creates vertical angle pairs that are congruent. So if you see two vertical angles created by two lines, and technically they'll be two sets, then you can say the angles are congruent. That is called the vertical angles theorem. Remember, the vertical angles are never adjacent to each other. They're across from each other. So either up and down or left and right. Now, the reflexive property of congruence is used if you have, say, two triangles and they're sharing a side between them. So we might be using it to say, oh, we know this side is congruent to itself because everything is congruent to itself, right? So you can use that to say the segments are congruent, or the shared sides are congruent, and that will help you get a side on your triangle for congruence. A midpoint creates two congruent segments because it falls halfway in the middle, so that means both of the segments created by that midpoint have to be congruent. A segment bisector is similar to a midpoint. It basically means that the bisector hits through that midpoint, and again, it creates two congruent segments. The perpendicular bisector is a pretty special one. It's not only does it go through the midpoint because it's a bisector, but it's also perpendicular, which means that it also creates congruent 90-degree angles. So perpendicular bisectors create congruent segments and congruent 90-degree angles. An angle bisector takes an angle and it cuts it in half. By cutting it in half, it is creating congruent angles as well. Both pieces will be congruent to each other. Now for setting up a proof, actually I should first say perpendicular lines. So if you have something that's perpendicular to another, this is not in your notes, you might want to add this in, then it creates 90-degree angles. But if I don't say if it's a bisector, you don't know that it creates congruent segments. So perpendicular lines create 90-degree angles. So when setting up a proof, you may need to work backwards to what you know. So first of all, go ahead and write down what is given. And the reason that you'll have doing two-column proof will be, okay, you've got your statement, what's given, and the reason will be given. Then write down, maybe down towards the bottom, or just keep it somewhere, what you are trying to prove. So, and then think, okay, which theorems or postulates could I use to get from the beginning to the end, or from the end to the beginning? What do you know or see that you can use? Don't forget to go through those definitions and see if you can identify congruent angles or congruent sides. And that's what I was talking about. You might need to use those connecting theorems or postulates. So in our last example for our notes, I have CD as a perpendicular bisector of AB. And I'm going to prove that these two triangles are congruent just knowing this piece of information. So first of all, I've already have it in your table, the given and the reason is given. And I went ahead and put the proof down at the bottom of the table. So first of all, if it's a bisector, that means it creates congruent segments. So I can say AD is congruent to DB, and that's part of the definition of a perpendicular bisector. The other thing, being perpendicular, means that there are 90-degree angles here. So those two angles are congruent, and again, that goes back to the definition of a perpendicular bisector. It creates congruent angles here. And I can say those angles are 90-degree angles, but not so sure I need it. So now I'm just missing one step between what I have here, these markings, and proving that the two triangles are congruent. I have a side and an angle. Now, one thing I can see is that this side is shared between both triangles. If I mark it congruent to itself, then I would have side, angle, side, and that would be good enough to prove. So I'm going to say that the side is congruent to itself. using the reflexive property of congruence, which means now that I can say the triangle is congruent by side, angle, side, side, angle, side.